All right, here we go with a video on factoring. This video is going to cover 4 kinds of factoring. Really, it's only 3. And by the end of this class, you will be factoring 7, 8 different ways. So factoring's not going away. So the first thing I'm going to do is I'm going to step you through one of them, and it's in the GCF category. One of the forms of factoring is just being able to factor out a greatest common factor. So when you're doing a question like number 1, the first thing you want to do is see if you can find a greatest common factor for the entire expression here. So we have a 6, a 4, an 8, and a 16. The GCF of all those is 2. Then we have an x to the 4th, an x squared, an x to the 5th, and an x cubed. When you're working with variables, it's the variable with the smallest exponent. And then finally we have y cubed. Y, we already found it, unless there was one that didn't have a y, but they all do. So then you just factor it out. Little tip, if you have 4 terms inside your parentheses, you need 4 terms when you're done. So 6 divided by 2 is 3. X to the 4th, take away x squared, you're left with x squared. Y cubed, take away a y, you've got a y squared. Minus 4 divided by 2 is 2. X squared and x squared, y and y, they cancel each other out. Plus 8 divided by 2 is 4. You have x to the 5th, you're taking x squared away, giving you x cubed. You have y squared, taking y away, you have y. Minus 16 divided by 2 is 8. You have x cubed, you're taking x squared away, so you have x. You have y squared, taking y away, you have y, and you're done. Sometimes after you factor out a GCF, you can have more factoring to do inside, but for this problem, that's it. Now number 2 is a very similar example. Go ahead and pause the video and try it on your own. And let's see if you got it. The GCF of all your numbers is a negative 2. The GCF of x is x squared and y. For your y's, parentheses, you have 3 terms, so you need 3 things inside. You should have 2xy minus 6y plus 1 inside, and you need that plus 1. Sometimes people think, oh, it's the exact same thing, so it just goes away. No, it doesn't. If you have 3 terms in the original, you need 3 terms inside your parentheses after you factor out a GCF. Okay? So that's greatest common factor factoring. Now we have what some people call unfoiling, okay? All of this stuff is just called factoring in general, but over the years I've heard people say unfoil a lot, so I'll just continue saying unfoiling. This is where you do that special little number trick. The number trick is what multiplies to 15, but what adds to a negative 8. And then you do your little parentheses, your little swoop swoop. You've got your x and your x, and then some people memorize the patterns like, well, if it's negative positive, then it's got to be negative negative. If it's positive positive, it's got to be positive positive. If it's positive negative, then you have to have one of each, but the bigger one's got to be. You know what? If you want to memorize all those rules, it's fine. I say just think about it. So what 2 numbers are going to multiply to a positive 15, but add up to a negative 8? Well, in order to multiply to a positive, the signs have to be the same, so it is going to be negative negative. And 5 plus 3 is going to add up to 8. So we have a negative 5 plus a negative 3, which is a negative 8. Negative 5 times a negative 3 is a positive 15. You're done. You just factored. So why don't you go ahead and pause the video again and try number 4 and 6, apparently. Don't know where 5 went. Okay, go ahead and pause. So we have x plus 6 and x minus 11 for this one, because 6 times a negative 11 is a negative 66, but negative 11 plus 6 is a negative 5, so we're good on that one. Number 6, well, we need to multiply to 15 but add to a negative 5, and you might have been sitting here for a little while trying to figure that out. Well, it can't be done, because list your factors of 15. You've got 15 and 1, that's not differing by 5. And you've got your 5 and 3, and we never work with decimals for these unless the problem starts with decimals. So this one is known as prime. Whenever it can't be factored, we just call it prime. Okay? So that's unfoiling, or the special number game, or the whatever you want to call it. So we have two more types to talk about, and one of them is difference of two squares. Now again, difference of two squares is just a shortcut. You can always think about this in a different way, and I'll show you how to do that for one of them. So x squared minus 25. First of all, in order for the difference of two squares to work, you need two criteria. Both of these must be perfect squares, and there must be a minus sign in between. There's no such thing as the sum of two squares. Okay? So, square root of x, square root of 25. All we do is we write our parentheses again. X squared is x and x. And then a negative 25 is going to be a positive 5 and a negative 5. And that's how you do the difference of two squares. So for number 8, that is difference of two squares. 4 is a perfect square, x is a perfect square, 49 is a perfect square, y squared is a perfect square. So you can do it that way. But I told you there's another way to think about it if you don't like memorizing tricks, and that's rewrite it like this. Call it 4x squared minus or plus 0xy minus 49y squared. And then you can do the magic number game, like what multiplies to this, what multiplies to that. But it's one of those things where if you want to do it, it's fine. I like the fact that these are just perfect squares. You can just go like this. The perfect square 4 is going to become 2 and 2. X squared is going to become x and x. You get 1 plus, 1 minus. Square root of 49 is 7. Square root of y squared is y. So you got that. And you're done. All right? So think about number 9 really quick. So for number 9, I hope you wrote down prime again. And if you have x plus 6 and x minus 6, then you forgot one of the first rules I said. There's two rules of difference of two squares, and one of them is that it has to be minus on the inside, not a plus. So that right there turns it from possible to not possible, so we just call it prime. Now, number 10 and 11, I said really that's just the same kind. You can think about these as perfect trinomials, and really the only difference is how you write the answer in the end. So what's going to happen here is we're still going to say what multiplies to 64, what adds to 16. So you're going to do your little swoops, and you're going to call your x's, and you're going to say, well, it's a positive 8 and a positive 8. Because 8 times 8 is 64, but 8 plus 8 is 16. But then you realize the exact same thing lies inside those parentheses, so we're just going to call it x plus 8 squared. That's the only difference when you have two things on the inside. So I don't tell you to go recognize perfect trinomials first. Just factor it. Do the special little number game, and then if you have the same thing left inside, you just write it once and put a squared on the end. Same with this one. So go pause it. And here we go. So we have an x minus 4 and an x minus 4. Because a negative 4 times a negative 4 is a positive 16, but they add up to a negative 8, so we just call it x minus 4 squared. Okay? So that's how you factor in a number of different ways, but those are obviously just one-step easy problems, and you know I'm not about to leave it like that. So here's a step up. I have 8 practice problems for you, and we'll do them 4 at a time. What I'm going to have you do is pause the video, and what I'm going to tell you right now is that these are multi-step problems. You might have to factor 2, maybe 3 different ways in a problem before you are done. So go ahead, pause the video, and try these 4 before we move on. All right, take a look. See if you were able to handle these 4 correctly. Now, I said they were going to be multi-step, so they're color coordinated for you. Number 12, the first thing you had to do is factor out your GCF of 4x. That left you with x squared plus 7x plus 10 on the inside, but again, that's just like an unfoiling. You can factor that, what multiplies to 10 but adds to 7. So this one split to x plus 5 and x plus 2, but do not forget your GCF. You must carry him with you. So your final answer is this line right here, 4x times x plus 5 times x plus 2. Same thing happened with this one, but your GCF was 5x squared, and then you were left with x squared plus x minus 6, which could be factored to x plus 3 and x minus 2. Number 14 was a little bit different because it's just the difference of two squares, but what's the square root of x to the 4th? It's x squared. So it gave you x squared minus 4 and x squared plus 4. But then you've got to look at this again. You have another difference of two squares. So the square root of x squared is x and the square root of 4 is 2 and 2. And then, of course, you still have your x squared plus 4. You cannot leave him alone. Same thing happened with number 15, except for this was what multiplies to negative 12 but adds to a negative 1. It's just that we want fourth squared nothing. So it's still dropping in the appropriate pattern. So what multiplies to 12 is a negative 4 and a 3. But since this is x squared, you had the difference of 2 squares again for the purple one. All right. So here comes 4 more. Go ahead and pause the video again, and let's see if you can handle these 4. Again, they will be multi-stepped. All right, so number 16. This was same, multiply to positive 36, but add to a negative 12. You get x squared minus 6 and x squared minus 6. Get you thinking for one moment that one of those is a perfect or a difference of 2 squares, but they're not, because this is a 6 and it's not a perfect square. So you do realize that they're the exact same thing written in here twice, so that we just call it x squared minus 6 in parentheses squared. This is kind of like a GCF. Now I'm going to show you this one in a different way. What if we were to call this 3xa plus 7a? You can take out a GCF of a, which would give you a times 3x plus 7. And a we call the x minus 2. So this is just 3x plus 7 times x minus 2 if we were to substitute x minus 2 back in for a. Number 18, again, it's what multiplies to 16 but adds to 8, but this time we have x's and y's. So we have x plus 4y, x plus 4y, so it's written as x plus 4y squared. Number 19 is another one where you might want to just rewrite. So let's just rewrite this as x minus 5 being an a. That's going to give us a squared plus 5a plus 6. Now you just factor it like normal. What multiplies to a 6 but adds to 5, it's 3 and 2. And then you go back and you take that a of x minus 5, plug it back into the a's, and you get x minus 2 and x minus 3. Okay, that's it. I hope you enjoyed this episode of factoring. There will be more episodes of factoring coming in the future, probably another one coming up next. So that's it. This is Longo, and I'm out. See you. Bye.